All right, let's go ahead and get started. Welcome, everyone. Thank you for being here. My name is Yama Habibzai. Let me just transition slides here. My name is Yama Habibzai. I'm the CMO here at Device 42, and I have the pleasure of having with me Steve Shwartz, our co-founder of Device 42 and author of the book, Evil Robots, Killer Computers, and Other Myths. Steve started his career back at Yale University at the Computer Science Department Artificial Intelligence program. He's been actually co-founder of three different companies in the AI area, so an expert in the space. He's participated in multiple IPOs and mergers and acquisitions, and today he'll be showing us how you can future-proof your IT with artificial intelligence. Before we get started, just a couple of housekeeping items. One is you can submit your questions, please, in the Q&A box of the GoToWebinar, and we will cover those questions. Try to get as many of them as we can towards the end of the presentation. We will keep it short and sweet in about to about 30 minutes, so we won't bore you too much with too much detail. But in any case, we'll go ahead and get started. If you have any questions, like I said, please submit those in the Q&A box. After the webinar, we will reach out to you. For those folks who've attended, you'll get a copy of Steve's book, as well as a set of answers to the questions and a recording of the webinar as well. So with that said, let's play a little game. The little game is a guessing game. If I was to ask you, from the dawn of mankind, what were the three top inventions that humans have ever come up with? What would you say? And reality, I'll prove it to you in terms of the fact that there's been a lot of innovations, but three innovations that really changed the human race. Can you guess what the first one is, or what the first one was? Any guesses? Okay, somebody's saying fire, wheel, electricity. Wheel, the number 0, electricity. All right, I'll give you the first one. The first one, fire. Why fire? If you think about it, the reason we invented fire was not about keeping warm, because a lot of these cavemen probably lived in warm environments. They invented fire to outsource digestion. The way we consume proteins, vitamins, minerals, and the way we get stronger and build our bodies is through meals that our stomachs can digest easily. Eating raw meat is not that easy, I would assume. So fire was the first invention that, in a sense, we outsourced digestion to make us stronger. So that's number one. What do you think was the second invention? And think about outsourcing. What else did we outsource? Any guesses? Wheel. Good guess. Yes, the wheel. With the wheel, we outsourced work, right? We are able to build civilizations, move heavy objects, and instead of carrying things in our arms, the wheel allowed humans to not only travel longer distances, but also move heavy objects and build things. So we outsourced work. That was innovation number 2. What do you think was the third and final innovation that we know of in that kind of process in terms of outsourcing? Any guesses? This one's a challenge. Transistor, electricity. That's what crops. Computing. Somebody said computing. Danny. Very good guess. Yes, the computer. With the computer, we outsourced our brains, right? Essentially, the computer is doing advanced technical analytics, allowing us to solve problems much faster. It is here that things become very interesting, right? If you look at the rate of innovation in the last, thousands of years, really the last couple of 100 years is when innovation really took off just across the board. But with the computer, they're saying that the speed at which the computers can calculate with things like quantum mechanics, quantum computing, and as well as artificial intelligence, Now we're outsourcing our brains, and therefore we don't even have to think. A machine can think for us and innovate at the pace that we've never seen in history. That could lead to solutions to various diseases like cancer and solving complex problems in the world. And this is where things are getting very, very interesting. So with that said, I hope you enjoyed that little game. At this point, I'll pass it over to Steve, who's actually the expert in the space, not me, who will give us a little bit more insight about artificial intelligence, AI, and IT. But we actually, before one more slide, a shameless plug about Device 42. Oh, who's Device 42, right? Steve Shwartz being a co-founder. We at Device 42 are a full discovery, inventory management, and dependency mapping solution. We have customers across 62 different countries. We arm these customers with the ability to look at and take our discovered data to move IT faster, meaning solving IT problems much quicker in a more efficient way. Cloud migrations become an ease because they have visibility before, during, and after a migration, lowering the overall risk of running IT with visibility. We have the most advanced agentless discovery that gives you a complete visibility of what the reality of the environment looks like. And our dependency mapping and insights take that data and gives you analytics and information that you can use to proactively solve critical problems. And finally, our integration with 30 different products is a capability that snaps right into your environment with your existing solutions like ITSM and others, where we become part of the flow of your IT environment. Like I said, 62 different countries, hundreds and thousands of customers use us, and would love to tell you more about it at a later time, but that's kind of a shameless plug about Device 42. Now, at this point, let's move it over to Steve. Steve, I'll pass it over to you to educate us, please.
Great, thanks, Yama, and thanks everybody for joining me today. Let me just start out by defining some terminology for you. Artificial intelligence has two main subdisciplines, machine learning and natural language processing. Machine learning breaks down into three main areas. Supervised learning is the most prominent type of machine learning. Supervised learning is responsible for most of the major breakthroughs in AI that impact our daily lives: facial recognition, speech recognition, Google Translate. And I'm going to talk a little bit about how supervised learning works. So get a basic understanding of how it works. I'm also going to talk about unsupervised learning, which is very important for IT, especially in one area known as anomaly detection. So we'll talk about that. I won't be talking about reinforcement learning today. That has its primary impact in game playing, theoretical robotics, and self-driving cars. I also won't be talking about natural language processing, which has three main ways of doing it. Today, most research in natural language processing is done via machine learning. Prior to that was something called statistical natural language processing. And back when I started out in the late 70s, early 80s, we did symbolic natural language processing, which is still used today. And in applications like chatbots and information extraction. Okay, so next slide, please, Yama. So how does supervised learning work? Let's say you want to build a system that will diagnose whether a person has a particular disease based on their the characteristics of their physical health. So you start with a training table. Each row of that table is one patient. And this is historical data for training. So the input columns might be things like the age of the person, whether or not they're a smoker. You know, there might be 10, 20, 100, 1,000 different columns of data. And then there'll be an output column that tells whether that patient actually had that disease. So you'll take this table of data, it might be 1 million rows, 1 million patients, 10 million, 100 million, and you run it through a supervised learning system. The supervised learning system applies statistical or deep learning algorithms to learn a function. Now, what do I mean by a function? A function, think back to when you learned how to translate Fahrenheit, centigrade to Fahrenheit. In high school, you probably learned the function Fahrenheit equals 9/5 times the centigrade temperature plus 32. That's a function. All it can do is one thing. It can take as input a centigrade temperature and output a Fahrenheit temperature. No intelligence in it. It's just a simple function. Well, it turns out that what these supervised learning systems learn is a single function to do a single task. Now, in the case of something like facial recognition or Google Translate, it's a very complex function, but it's still a function. You can take an input and produce an output. Take an input as a record of somebody's medical history, produce the output. You can take an image of a person, run it through the function and produce the name, but that's all it can do. Again, no intelligence in that function. It's kind of like that temperature conversion function. And what that function will do in this diagram is to predict whether the person has the disease. Next slide, please. So the way that's the training phase. You took that big table of data and you trained that function. Now in production, what you do is you take a new record of someone that wasn't in the training system, you run it through that function, and you use it to predict whether that person has the disease or is going to get the disease. And in this inference mode, as it's called, in the production mode, you have much lower computational requirements because you're not reading that whole training table of data. You're just running one record through a function. All that function is going to do is do a computation, and the result is going to be a yes or a no. That's how facial recognition works. So the inputs are going to be the individual pixels in an image. You're going to run that through a function, and the prediction is going to be the name of the person in that image. Next slide. So as I mentioned, most of what you see in AI, most of what affects you on a day-to-day basis is supervised learning. Facial recognition, when your smartphone labels your photos with names, that's facial recognition. It's learned to do that through supervised learning, and it's just that a function. That's the only thing the function can do is recognize faces. Again, no intelligence. It's a mathematical function. And the same thing for these other application areas. Next slide. So because in supervised learning, you're just learning a function, that function has no intelligence, we don't have to worry about AI becoming really smart. So R2-D2 in Star Wars, science fiction, there's no way that supervised learning can evolve into R2-D2 or Rosie the robot from the Jetsons or the androids in Westworld or the fearsome Terminator. Can't happen. And it's true of the other types of machine learning. Unsupervised learning's still a function. Reinforcement learning still learns a function. All experts in AI agree that none of the current methods of AI can evolve into true human intelligence. Next slide, please. So let's talk about unsupervised learning, which is important for IT. And the use case that's really important is anomaly detection. What you can do with unsupervised learning, and I'll explain how it works in just a second, is you can look at aspects of your IT configuration. So for example, if you're trying to do threat detection, you have the system learn the normal state of affairs and throw up a flag when something unusual comes in so that a human can examine it and determine if it's a threat or maybe take an automatic action. You can do the same thing with other aspects of IT. So for example, I'm going to show you a little bit of a little demo of a system that takes in information about all the devices in the system and all of the processes that are running on the devices. And what the unsupervised learning algorithm, the anomaly detection algorithm will do will be to create clusters of quote unquote normal configs of those processes. And then it will try to find devices that aren't quote unquote normal and flag them. So I think in this demo, we have something like 600 devices, and it will flag 4 of the devices for IT to take a look at and see if there's really anything unusual about it. Okay, so let's jump into that demo. Yep. Okay, so what we have here is some code written in Python. It's ingesting that table of 600 devices with all of the pieces of software or all the process names for the software. It's creating a graph of the clusters and how many devices are in each cluster. And I'm going to come back to this. I have a slide that shows this graph. So we'll come back to this in just a second. And now it's printed out the 4 devices that are somewhat unusual. And you can see what Yama's just done in that first device is it's highlighted a process that's actually a Bitcoin mining process. So now IT can go back and look at these 4 highlighted devices. They'll see, for example, Bitcoin mining on one of the devices, and they can take the appropriate action. Okay, let's go. So I'm going to come back to that graph you saw on the next slide. So what's happening under the hood is unsupervised learning, which works a lot like supervised learning, where you have a table of inputs. So in the demo we just showed you, each row is a device, and the columns are the processes, the process names on all the devices. And what you actually do to run an algorithm like this is you find all the different process names on all the devices, and let's say there are 500 of them, you label them 1 to 500, and then you have 500 input columns plus the device name, and under each of the 500 input columns, there's a 1 or a 0 that specifies whether the device has that process. You run that through the unsupervised learning algorithm. It learns a function that places each device into a large multidimensional space. That's a little bit hard to understand, but think of it as just creating clusters of like devices. And there's no output column here. So the nice thing about unsupervised learning is you don't have to have the answers. You just have to have the data. And the system will learn how to create these clusters. Excuse me. Next slide, Yama.
Yep.
Next slide.
Yeah, I'm trying to get to it. Sorry. There you go.
Okay, great. Thank you. And what you saw in the application when we ran that anomaly detection code, under the hood, it was creating these clusters. And you can see in this graph, the very first cluster has something like 200 devices in it. It's kind of hard to see, but the y-axis is the count or the number of devices that are in that cluster. And there are, there's probably about 20 quote unquote normal devices. And then you can see I've added red arrows where there are 4 data points that don't fall into any of the clusters. And some of them as it turns out with this particular algorithm, the ones with the larger numbers fall even further away from most clusters than the other. So these are all things for IT to take a look at. Maybe find in one of them that Bitcoin mining is happening, and you take the appropriate action. And we'll make code for this algorithm or this demo that you just saw available on GitHub. Send you a link, and that code will include 3 different anomaly detection algorithms. I'm not going to get into the details, but they're called COPOD, local outlier factor, and isolation forest. And just to give you an idea of how they work, LOF, which I think is the one you saw in the demo, works by taking a data point, finding the closest cluster, and seeing how much further away from the other data points in that cluster it is than the points in the cluster. Anyway, that's too much technical detail, but you'll get the code if you want it. Okay, next slide. So just as a summary, most applications of AI use supervised learning. Explained a little bit about how that works. Because supervised learning, unsupervised learning, reinforcement learning, deep learning, all they do is learn a function that's not much different than a temperature conversion function. We can't build human level thinking computers with those algorithms. So if we're ever to build something that's human level, it would require a major breakthrough, and probably nothing to do with the type of AI we have today. So you don't have to worry about the Terminator. We talked about unsupervised learning, which is critical for IT. If you take these anomaly detection algorithms and apply them to the data that you can get out of asset management systems like Device 42, the result can be a lot less work. So instead of monitoring hundreds and hundreds of devices, you just look at the ones that are flagged by the system, and you'll end up with better visibility in addition. Okay, so let's stop there and take questions.
All right, thank you so much, Steve. The one thing that I'm really glad about is I don't have to worry about the Terminator, so that's a good thing. All right, so would love to take your questions at this point. Feel free to use the question and answer box to submit your questions for Steve. Like I said, Steve's an expert in this space, so feel free to submit your questions. I know some questions are coming already. Let me just find the little box myself to get to those questions. 1 second. Hold on. Okay, one question is Device 42 SaaS-based? The answer is no. We actually are on-premises solution. The reason for that is because a lot of our customers don't want their data to leave their private environment. Therefore, it is an on-premises solution. Let's see, 1 second. The next question is, will AI take my many IT jobs? Steve, that should be for you. What do you think?
Okay. Yeah, the way to think about this is, if we could build human level AI like R2D2, we'd have computers that could read every manual, take every class, and do every job. But we have no idea how to do that, and it's very unlikely that will ever happen. All we can do is create these functions that can do exactly one thing: take a very specific input, produce a very specific output. So the only thing that AI can do is they can take over specific functions of jobs, but most IT jobs or any other type of job are a lot of different functions. So I don't think you're going to see AI take over a lot of IT jobs. You know, what you will see and what we have been seeing for 40 years is conventional software, non-AI software, has a lot more ability to take jobs than AI software.
Great, thank you. There's another question very similar. Do you have any comments on the displacement of human workers by AI system? I think you just covered that. If AI is just learning single functions, how do self-driving cars work, Steve?
Yeah, that's a great question. So the interesting thing about the way self-driving cars work is that it's not just a single function learned by a supervised learning system. It's multiple functions. So as an example, if you look at how a Tesla works, there are about 50 different supervised learning functions just for perception. So the Tesla systems have trained one system to recognize pedestrians. So that's one function learned by one supervised learning system. Another function learned by a supervised learning system is recognizing stop signs. Another one is lines in the road. So there are a lot of different individual machine learning systems that do these perception tasks. And then there's conventional software that ties it together with planning. And there are little pieces of that control and planning software that are now being done with, again, individual supervised learning, or actually reinforcement learning functions. But the overall control and planning is still done by conventional software.
Great. Another question that's specific to Device 42, I can take that. Device 42 is discovery only for on-prem, or will it cover for hybrid environments? We do cover hybrid environments. As a matter of fact, that's one of our secret sauce in terms of a full-on discovery to across the entire IT stack for on-prem and public cloud workloads as well. Yes, we cover both on-prem and hybrid environments. Next question for you, Steve. This is an interesting one. How would you suggest traditional sysadmins and DevOps practitioners supplement their skill set to leverage and thrive in an environment of growing low-code and AI-based solutions?
Yeah, that's a great question. Especially on the AI side. You know, I think it's a matter of education. AI can do certain things that are going to help out an organization, and it can't do other things. So you need to start by understanding what AI can do and what it can't do. So, you know, it's never going to become this mythical science fiction, super intelligent thing. But, you know, if you can learn that it's going to just all you can do with AI is learn a function. Now you can go look in your organization for areas where such a function might help move the business forward. So I think it starts with self-education. There are a lot of good books that you can read. You can read my book. I have a website with a ton of in-depth information about AI that's free to access, aiperspectives.com. So you can look there also.
Thank you. Another question is, what level of AI can we expect from Device 42? I can take that, Steve. So Device 42, we are very focused on in this area. We do believe this is an area of a lot of innovation for IT. We have some capabilities already implemented around normalization of data. We collect a lot of information, a lot of data across servers, applications, data center environments, power, IP addresses, and so on. One of the areas that we try to focus on is how do we make sense out of all that data, right? So as an example that I typically use is, Windows system might be labeled as Windows 2000, let's say. Another person can name it Win 2000. Another person can just call it Microsoft Windows 2000. But they're all the same thing. So at a basic level, we try to take that data, normalize it, and categorize it automatically for our customers, such that they don't have to deal with that level of complexity. So just reducing complexity and automating that process through this built-in AI capabilities is already something in the product that we're investing more time and effort into. This last question is there a chance that Steve will sign his book prior to sending it to participants of this session? I think we can try, Steve. I'm not sure logistically how we can sign that many books, but sure, we will try. How about that? And but can't promise, if that's okay. All right, I don't see any more questions coming in. Again, Steve, thank you so much for your time, for your thoughts. This was a great educational session. Like I said, you or Steve covered, you will get 3 things from us. 1 is the recording of this webinar. Number 2, a copy of Steve's book. And 3, a link to the GitHub to download the sample code. And we will also cover the answers to these questions in an email to you as well. What we ask is, if you have an interest in Device42, absolutely reach out to us at info@device42.com. That's info@device42.com. And happy to set up a demo and give you a little bit insights about how we can help you in with your environments as well. Thank you again. Enjoy the rest of your day, and thank you for joining us. Take care. Bye-bye.
Bye, everyone. Thanks.
Bye-bye.